Hello and welcome. So we have Farmer Neil building a rectangular goat pen enclosed by a fence and divided in two equal parts by one additional fence parallel to the other sides of the fence, right? See picture below. So if he has 708 meters of fencing available to use, what are the dimensions for the outer rectangle that will create the largest possible area? And we also want to find that area as well. So when we're looking at this, we know a couple of things. So first thing, right? Our goal is to create this fence. Now the fence is all of these sides right here. We're looking for all of those. So we're looking for essentially the perimeter of our rectangle here, as well as doing one extra side. And all of that, we know the perimeter of this whole thing with that extra divider in there is going to equal 708 meters. And it has to, because that's all of the fencing that Farmer Neil has here. We can't add more fencing, and we want to use that amount of fencing. Right? We want the largest possible area, so we don't want to use any less. Right? More fencing equals more area, kind of a thing. So we want to use the exact 708, no more, no less, kind of an idea. Now we're looking for the dimensions of the rectangle. So my goal is defining the length of it as well as our width there. Okay. Now what we're going to do is we can say, all right, what do we know about the shape? It's a rectangle, right? And our goal is to find the area, the largest possible area, and we know the area of a rectangle is the length times the width, right? Or in our case, we're using, instead of length and width, we're using x and y. So I would say area equals x times y in our case here. Now let's also get an equation for our perimeter. Now I know that we're going to have 2 of the x sides, so 2 times the x. Now because of that extra divider, right, we have 1, 2, 3 sides of the y. And we have the 2 from the outer edges of the rectangle, but we also have the 1 divider in between, so that'll be 3 of the y sides. Okay, so we have 2 ways to relate these, perimeter and area, and now we can actually start working in what we want to. So I know that the perimeter, my 2x plus 3y, is 708. We're using 708 meters of fencing. We know that is our perimeter. Okay, now we also know area is x times y. Essentially, pick whether you want to solve for x or solve for y. I personally like solving for x, so that's what I'm going to do. Right? It doesn't matter, again, going to get the same answer either way. All right, so I'm going to subtract 3y both sides. I'm going to get 2x equals 708 minus 3y. All right, and then from there, finish solving for x. I'll do multiplication with division. And what I do to one side, I do to all of my other side. You don't get to pick and choose what that 2 is going to divide on, so we have to divide both. All right, so x equals the 708 minus 3y over 2. Right? And then, because we know the area is x times y, and I just happen to know x, all we're going to do is just plug that right in there. So area equals 708 minus 3y all divided by 2, and that is times by y. And that's as crazy as that's going to get as far as area is for us. All right? So now we say, okay, let's kind of finish multiplying this through, simplify it out a little bit. So first thing I'm going to do is I'm going to distribute that y in. So area equals, and I'm going to also move it around a bit, so negative 3y squared plus 708y. That's all divided by 2. To make this a little easier to see, I'm going to actually divide both of those numbers by 2, so negative 3 halves y plus, and then all I'm going to do is I'm just going to find half of 708, which is 354. Okay, oh, forgot my square on that. There we go. So negative 3 halves y squared plus 354y. Huzzah. Okay, Now, what we're looking at here is technically we're looking at a quadratic, right? You guys are used to quadratics being in that ax squared plus bx plus c format. Technically, our c is 0 here. All right, so here is our quadratic, and we want to know what is the maximum possible area. Well, our area is in the form of a quadratic, right? Remember, those are the U-shaped graphs, and your maximum and or minimums, right, in our case, are, because it's a negative in front, our direction of opening is down, right? That tells me that we have a maximum area that it's going to hit, and that point is called our vertex. You can find vertex a couple of ways. You can use the shortcut for standard form, which is negative b over 2a. So in our case, our b value is 354. So negative 354 over 2 times our a is negative 3 halves, right? And this will give me the maximum, like where it happens, value for the area, right? So we say, all right, well, that's perfect. So into a calculator goes. So we have, let me actually simplify it. So negative 354 over negative 3, because those 2's will essentially cancel. And now this gets jacked into a calculator. So we have 354 divided by 3, because those negatives are just going to cancel out with each other. And we get a nice number of 118. That means that when I'm looking at a y value, like for my y values, right, we have 118 is where the maximum y value is going to happen. So 118 right there. And then in order to find the x, all we have to do is just plug it back into one of our equations. We know what x equals, that thing, right? We just plug y in. So all I'm going to do is 708 minus 3 times 118 in my calculator. All right, and that will give me back 354. And then we just need to find half of that, which is 177. And that's as crazy as that one is going to get. Like, we found the x, we found the y, right? Once you have that numeric value of y, plug it back in to your what you found for your x, and that's it. Those are your dimensions. Okay, now I said there were 2 ways to find the vertex. We had the first, which was our shortcut, right? The other way would be to find your x-intercepts, right? Your solutions to x. So in other words, I would set area equal to 0, right? Solve for y, you'd get 2 numbers, and then you'd have to add those together, right? And then find whatever those 2 solutions are. The first solution, the second solution, add them together, divide by 2. That would also give you that 118 number. It's a little more work than just doing negative b over 2a, right? If it's in standard form, knowing that shortcut, so much easier. But up to you. All right, so there we go. So we have our 2 dimensions. We know the width and the length of what this goat pen is going to be. So now we just need to figure out what is the actual largest possible area. Well, we know that these 2 dimensions will give the largest possible area, and that area is x times y, or in other words, length times width. So this is just going into your calculator, 177 times 118, or in other words, 20,886. Right? And if we wanted to put any kind of units on this is all in meters, so technically that's meters, right? And this is meters squared. Right? So there we go. That's as crazy as that needs to get, but that is how you do it. Thanks for watching.